So in TCS Theoretical Computer Science module number 3 we will learn about grammar. So what are we going to learn about grammars and Chomsky hierarchy, regular grammar, equivalence of left and right, linear grammar, equivalence of RG and FA, that is regular grammar and finite automata. Then you have context free grammar, CFG, definition, sentential forms, leftmost and rightmost derivations, sparse tree, ambiguity, simplifications and applications, normal forms, Chomsky normal form, Gribar normal forms, context free language, pumping lamina and closure properties. So first is students will learn the basics of grammar and Chomsky hierarchy in the 3.1 part of module number 3 grammar. We are going to learn about the basics of grammar and Chomsky hierarchy. So grammar, it is a finite set of formal rules for generating syntactically correct sentences or meaningful correct sentences. So grammar is nothing but a finite set of rules which you have to follow for generating syntactically correct sentences or meaningfully correct sentences. So it is like your English grammar. In English grammar also you will arrange the sentences in such a way that there is some meaning. She is going out will be a proper sentence with proper rules which are followed. You can't say out she goes. This is syntactically wrong. So you have to frame a sentence. You have to frame that sentence which is syntactically correct. Similarly over here also you have to follow certain rules so that you generate syntactically correct sentences. Formal definition of grammar. Any grammar can be represented as 4 tuples. So what are the tuples? VTPS. So your grammar is represented using 4 tuples. V stands for finite non-empty set of non-terminal symbols. Now we will see what are non-terminal symbols. T stands for finite set of terminal symbols. P stands for finite non-empty set of production rules, and S stands for start symbol from where we start producing our sentences or strings. So first is terminal symbols. So terminal symbols are those which are components of the sentences generated using a grammar and are represented using small case letters like A, B, C. So wherever you will see the representation is in the form of small case, you will say that it is a terminal symbol. That is the identification of terminal symbol. Whenever you see a small case letter, you say it is a terminal symbol. What are non-terminal symbols? Non-terminal symbols are those symbols which take part in the generation of sentence but are not the component of the sentence. So they take part in the generation. Using them the sentence will be generated but they are not a component of the sentence. Non-terminal symbols are also called auxiliary symbols and variables. These symbols are represented using capital letters A, capital B and capital C. So whenever you see a capital letter you will say it is a non-terminal symbol. Small case means terminal. Uppercase means you can say this is uppercase. Uppercase means non-terminal. Example, let's see example. So you have been given this set. We know what is this. This is, see, here it was VTPS. VTPS. Now SAB, you see these are capital. So you say these are what? They are non-terminal symbols. Small a, small b are lowercase. They are terminal symbols. S is the start symbol. S belongs to N. And production is P. So here S is the start symbol. And here you have this P. P is the production. What is production? S will be AB. A can be replaced. Capital A can be replaced by small a. Capital B can be replaced by small be. So grammar G2, this is your new. Here again S and A are non-terminal, small a small b terminal, then you have epsilon is an empty string, S is the start symbol, and this is what? This is the production P. Derivations from a grammar. Let us consider the grammar G2 equal to SA, AB, S, and these are your production. So some of the derivations are S, A. So what is it given? See, S is given as capital small a, capital A, small b. Now we have to replace this capital A. Why? Because capital A, what did we learn? Non-terminal symbols are those symbols which help in the generation of sentence, but they are not a part, they are not a component of the sentence. So this should not be a component. So this is helping in generation but not a component. So you replace the capital letters because capital letters will help in building the sentence, but they will not be present in that sentence. So capital A is what? See, A, as it is I wrote A. Capital A is A, B, and this B we wrote as it is. Now this is again a capital A. So we'll write A, capital A will be replaced by A, B. This is the replacement, B as it is. Now capital A can also be replaced by an epsilon. So when you replace this with an epsilon means an empty string, we say A, B. You will get this as your final, and this final what you got is a terminal. Terminal symbols, they are a component of the sentence. So they are present in the sentence. And this will help in generation, but they will not be present in the sentence for non-terminal. Now let's see types of grammar. On the basis of types of production rule, you have type 0 grammar, type 1 grammar, type 2 grammar, type 3 grammar. On the basis of number of derivation trees, we have ambiguous grammar and unambiguous grammar. We will know this later part of the chapter it comes. On the basis of number of strings, we have recursive grammar and non-recursive grammar. So this was the basics of grammar. In the next lecture, we'll study about the Chomsky hierarchy.